Hi, today we're learning about properties of reflections. A reflection is a flip. It's a transformation that flips a figure across a line. The line of reflection is the line the figure is flipped across to create a mirror image. It can be any line, but in 8th grade, it's either the x-axis or the y-axis is the line of symmetry. Whatever one is your line of symmetry stays the same. So if it's your x-axis, your x-coordinate stays the same. If it's the y-axis as your line of symmetry, the y-coordinate stays the same. Let's look at example 1 to graph a reflection. The figure shows triangle XYZ. We're going to graph the image of the triangle after a reflection across the x-axis. So step 1, let's reflect point X. Point X is 3 units below the x-axis. 1, 2, 3. So we're going to count 3 units above the x-axis. 1, 2, 3. Put a dot and write X prime. Step 2, reflect Y. Point Y is 1 unit below the x-axis, so we're going to count 1 unit above the x-axis, put a dot, and write Y prime. Step 3, let's reflect point Z. Point Z is 5 units, 1, 2, 3, 4, 5, below the x-axis. So we are going to count 5 units, 1, 2, 3, 4, 5, above the x-axis, put a dot, and write Z prime. Connect X, Y, and Z to form your image. Each vertex of the image is the same distance from the axis of symmetry as the matching or corresponding vertex in the original figure. Remember, the pre-image is the old image with the regular labels. The new image has the prime notation. Pause. It's your turn for example 4. When we reflect this pentagon across the y-axis, you're going to end up with this shape. It looks exactly like our original, but it's flipped, which means the C that used to be on the right is now on the left. And the A and E that used to be on the left, well, they're now on the right when you flip it. Make sure that you label your new points with prime notation. Make sure that each point is the same distance away from the y-axis. Remember, reflections preserve or keep congruence. They're the same size, but they have a different orientation. What used to be on the left side of the figure is now on the right side of the figure. Okay, we're going to look at the algebra part of reflections. And so I want you to just consider point A. Point A used to be at -5, 6. But when it reflects across Y, it becomes A prime, which is 5, 6. +5, 6. So what you need to understand is that when we reflect across Y, Y is the axis of symmetry, and the Y coordinate stays the same, but the X coordinate becomes the opposite. So Y stayed the same, but X became the opposite of what it was. It used to be -5, and now it's +5. But the Y stayed the same. And this is the algebra part of what you do. When we turn to the back of your notes, the algebra is at the very top. Again, when your axis of symmetry is the x-axis, X stays the same. When x-axis is the axis of symmetry, Y becomes the opposite of whatever it was. When the y-axis is the axis of symmetry, then Y stays the same. And X would become opposite. Let's try some more problems. Pause and try number 1 and 2. On number 1, the axis of symmetry is the x-axis, so x will stay the same and the y coordinate will become opposite. So we're looking for -2, -3. The only correct choice is D. On number 2, the axis of symmetry is the y-axis, which means y stays the same, and the x coordinate will become opposite. So the only one that has -5, -4 is choice F. Try number 5 and 6. Try number 3. On example 3, they want us to reflect STUVW using the algebraic expression xy transforms to -xy. Well, you'll notice that y stayed the same. That means that y is going to be our axis of symmetry. X is going to become opposite. So I'm going to take point S and I'm going to go to the y-axis, it's 5, and I'm going to go the same distance past y, and I'm going to put a dot in the letter S prime. I'm going to go to T, go to the axis of symmetry, it's 5. I'm going to go the same distance past that and put a dot and call it T prime. Let's go to W. I go 2 to the y-axis, I go 2 past the y-axis, put a dot, that's W prime. For V, I'm going to go to the y-axis, go the same number of points past the y-axis, put a dot and call it V prime. Go to U, you go to the y-axis, go 2 past it, put a dot and call it U prime. When you connect the dots, it's going to be the same exact figure, it's the same shape, but it ends up being a different orientation. I think I have my lines connected correctly now, and what you'll notice is, again, reflections preserve congruence, but not orientation. Let's look at the point S. S started at -5, +6, but after the transformation, S prime became 5, 6. And then let's look at U. U used to be on 2, -6, but after the transformation, U prime became -2, -6. So the only possible answer choice is A. At the very bottom of your notes, does a reflection affect orientation? Yes. The flipping changes orientation. Does a reflection affect location? Yes. Our points are in a new location. Does a reflection affect size? No. A reflection preserves congruence. Thanks for listening. Bye.